In our previous class, we have discussed what is complex number and mind map of it and the overall complex number. We have discussed brief about the algebraic expression like closure law, commutative law, associative law, distributive law, and additive inverse and additive identity, multiplicative inverse and multiplicative identity. We are also seen as the expressions like difference of complex number, multiplication of complex number, division of complex number, and addition of complex number. We have seen that modulus and conjugate of complex number. And the main important thing in complex number is its polar form and organ plane. Before that, there are some identities like z1 plus z2 square is equal to
Z2 whole square.
z2 whole square is equal to z1 square plus z2 square plus 2 z1 z2.
Chalk piece which come.
It's an a plus b whole square and a minus b whole square is equal to z1 square minus 2z1.
A minus b சொல்லலையே அது ஐடென்டிட்டி நீ
Yes.
காம்ப்ளெக்ஸ் நம்பர் சொல்றப்ப காம்ப்ளெக்ஸ் நம்பரா சொல்லு.
z1 minus z2 whole square is equal to z1 square minus 2 z1
Use chalk.
z2 plus z2 square. We can also use in case of z1 plus z2 plus or minus z2 cube. So it simplifies our formula. z1 plus or minus z2 whole cube is equal to z1 cube plus or minus 3 z1 square z2 plus 3 z1 z2 square plus or minus z2 cube. And z1 square minus z2 square is equal to z1 plus z2 into z1 minus z2.
So these are all almost similar to algebraic identities.
Then later organ plane is also called as a complex plane, that it is nothing but complex number assigned to each of its point in a graph in x-plane plane. This is called organ plane. There are some graphical representation for organ plane which we will see deep in
x-axis, y-axis, origin
and the r is nothing but polar form representation.
The p is the point.
Yes. What is polar form is nothing but z is equal to x plus iy. If in case the z in polar form is equal to modulus of z is equal to r, which is nothing but polar representation, which is equal to real square plus imaginary square x square plus root of y square. Z is equal to I x plus iy is a general formula, but in polar form we represent this as cos theta plus I sin theta, which you can see here is a theta opposite.
What do you call this theta?
Theta is nothing but the argument of z, that is complex number.
So the complex number can be represented in the polar form, and in this organ plane it is represented as what? Z of point x comma y. Can you show that point?
Here is that point z of x comma y. Here is the r, which is nothing but cos theta plus sin theta.
That is not r. That is r is equal to the whole square root of x squared plus y squared.
Yes. Then later there are some arguments of complex number which we can represent as arg of z or amp of z. Both
what is amp?
Nothing but argument of z is equal to the theta.
Amp is only, what is that?
Amp is also an argument.
That is called amplitude. Argument or amplitude.
So that
is equal to theta.
Yes, sir. The theta is equal to 2n pi plus tan inverse of y by x, because we are using in sin and cos ratios. Here the n belongs to the integer values. So argument of principal is almost same to the principal argument of z, because tan theta is equal to y by x. So theta is equal to tan inverse of y by x. So we can say minus pi lesser or 0 greater or equal to pi.
Less than or equal.
Less than or 0.
Less than or equal to pi.
Less than 0. Greater equal.
சொல்றப்ப இப்படியே வரிசையாவே வாசிக்கலாம். அதுல என்ன இருக்கோ அப்படியே போடு. Minus pi is less than 0. 0 is less than or equal to pi. That's all. It means 0 lies between minus pi and plus pi.
Which is nothing but principal argument of z. And later we can
அது closed interval தானே?
இது sir. Yes sir.
அப்ப அது less than or equal to போடலையே, வெறுமனே less than தான் போட்டுருக்கா.
Yes sir. Then next here is an Euler's theorem. Some will say Euler's theorem also. Here the exponential power imaginary theta is equal to nothing but cos of minus theta plus I sin of minus theta. Here the theta value is negative and then the E of
We know already cos of minus theta is equal to cos theta. But sine of minus theta is equal to minus sine theta. So that is
let's
why
write cos theta in positive minus imaginary
sine
sine theta. Then we will represent complex number in also exponential representation. Here the z is equal to r e I power theta is equal to z of modulus e power I theta. Here e power I theta is equal to cos theta plus I of sin theta. In this we can also see some trigonometric representation in complex number. Same z is equal to I plus
that is the general
iy,
representation.
which we will represent in r of cos theta plus I sin theta. Here the r denotes its polar form. And next, De Moivre's theorem is nothing but
De Moivre's theorem. De Moivre's theorem.
It's nothing but cos theta plus I sin theta power n is equal to cos n theta into theta plus
cos n theta plus
I sin of theta. Here the e power I theta power n is equal to e power I n theta. We saw already e power I theta is equal to cos theta minus I sin theta. From Euler's theorem, we have seen this De Moivre's theorem, and we can see also some graphical representation of this.
Okay, good.
The capital gets.
What do you mean by argument?
Argument is nothing but the theta in the
Theta is
given plane is
the angle. The angle
argument,
subtended by that a complex.
which represents the complex number in some trigonometric values.
Okay. So what is the exponential representation of a complex number?
Exponential representation is nothing but r of e power I theta.
No. E power I theta is equal to
modulus
that is the relationship between
both
exponential form and trigonometric representation. So z
we have
is equal to r.
Z modulus is nothing but that square of positive and imaginary.
Good, very good.